Hi guys, my name is Elia Kelso and this is my lab video report presentation for Lab 2 Lines of Charge. Okay, so for starters, I wanted to kind of touch on the main objectives of the experiment, which first is to compare the point charge model to the line of charge model when it comes to calculating electric field or electric force. Next, to construct a computational model in GlowScript to observe and quantify interactions between two U-tapes. And lastly, basically using the computational model to determine the magnitude of charge on a piece of tape and what is the necessary magnitude of charge in order to float one piece of tape above the other piece. And then I included just a little diagram kind of explaining the line of charge model mathematically, and it's basically you're dividing the line into a bunch of thin slices with each side representing a point charge that contributes its own electric field, and then you basically have to take an integral in order to get the net electric field. And then for the experimental procedure from Lab 1, I just included it because we're using the same data from Lab 1 to construct our computational model. So that's the experimental procedure as a reminder, and a picture of kind of the floating experiment that we're discussing. Okay, so these are some of the fundamental physics principles. I included a picture of Coulomb's law just as a reminder of kind of what we're building off of, since that was like the foundation. Newton's second law, which is like net force of zero, means that this system is in equilibrium. We have gravitational force, Fg equals mg. We have electric force, which is basically calculated by taking the electrical field of the tape times the magnitude of charge. Then we have the electric field equation, and then net electric field. Since we're dealing with a line of charge, like I said before, you're taking an integral, which is the sum of basically all the point charges that are stacked across the line. Okay, so for assumptions and Lab 1 data, once again, I included the Lab 1 data and results since this is what I used to build the computational model. For assumptions, we assume that gravitational force and electric force equal out in order for the object to float. We have each tape is treated as a line of charge instead of a point charge, which means the charge must be distributed evenly across the length of tape. And we neglected air resistance and friction. And I included possible errors when it came to this computational model, which was based on our Lab 1 data, is inaccurate measurements taken during Lab 1 and potential loss of charge on the tape due to handling when we were conducting the experiment. Okay, so this is the computational model code and results. I included some of the code that I used to run my computational model to get the results. So we obviously have the constants. I included, basically for a lot of this lab, we just had to edit lines by incorporating our personalized data. So that's what I'm showing here. And then the code I used to calculate the electric field. And then I have my results for magnitude of electric force, magnitude of gravitational force, and then charge on one piece of U-tape. And this is the results I got after I ran my computational model. Okay, and then for the discussion questions, you were asked if you had to model each of your tapes as a single point charge like in the previous lab. Compare the estimated value of charge you get when you use your experimental data to produce a point charge model to the value you got with your line charge model. So my values differed between the two models. For the point charge model, I got 3.762 times 10 to the negative 10th coulombs, and then for the line charge model, I got 7.74 times 10 to the negative 11th. Basically, the reason these values are going to differ is because we're using a completely different mathematical model to calculate these. So the theory and the equations are going to differ between the two, so it makes complete sense that our values are going to be different as well. And then for number 2, why do these estimates differ? Which value is more likely to be closer to the real value and why? I said Lab 1 treated the charge of the whole tape as if it was localized at one singular point, while for Lab 2 the charge was expressed as an even distribution across the length of the entire tape. The calculated charge from Lab 2 is most likely more accurate because it is a closer resemblance to what charge distribution would look like for real tape. Thank you guys for listening. I hope you enjoyed my Lab 2 video presentation report.